Hi there. We looked today in class at some of the more conceptual pieces of Unit 3 and Unit 4. And so this little half sheet is what we kind of worked through. I generated it so that we could walk through one as a class and then everyone could try one on their own. One as a class, one on their own, one as a class, one on their own. And so I would encourage you to kind of follow a similar model at home. I'll walk through one explaining it, and then I would encourage you to pause the video and try the next one on your own, see if you can, if you've truly understood what we've walked through, and then you can start the video again, double check your work. Okay. So a couple of just kind of reminders here as far as the conceptual stuff that we will be looking at. From Unit 3, we looked at derivatives, and derivatives, remember, are slopes of tangent lines. Okay. Meaning that if our graph is going up, if we have a positive slope, our derivative is positive. If our graph is going down, we have a negative slope, therefore our derivative is negative. If we can draw in a little tangent line that's flat, a horizontal tangent line, then our derivative is 0 because that slope would be 0. Or if we had a cusp, then that cusp would have a does not exist derivative, right? Because or I should say not differentiable, because you can't take a derivative at a cusp. There's an infinite number of tangent lines that you could draw in around it, right? So that was Unit 3. Unit 4, we looked at what it means to be taking an integral of a function, right? And an integral is area, right? So that's the Unit 4 conceptual piece. And then a quick reminder from your early math days, if we're talking about just f, not f prime, or integral, remember that that's a point, it's a y value, right? F of x and y being somewhat synonymous there. Okay, so here we go. We are given a function here. This is a graph of f, right? And then we are told that, first of all, that f is a continuous function, that g is the integral from 1 to x of f of t dt, and h is the function 2 plus the integral from 1 to x of f of t dt. And we're asked to find first g of 3. Okay. So we're going to go ahead and take our 3 here, and we are going to plug it into our g of x function, 1 to x. So 1 to 3 of f of t dt. Okay, well, I have f over here, and I'm asked to find the integral from 1 to 3. Well, remember, an integral is area. So I'm going to be looking at what's the area from 1 here over to 3 over here, and that is a triangle. And so I can calculate the area of that triangle. Also, I need to make sure I take into consideration its location. It's below the x-axis, so this is going to be a negative area. So negative 1/2 base times height for my triangle here. My triangle, my base here is 1, 2, and my height is 1. So negative 1/2 times 2 times 1 is negative 1. Okay, if you need to, pause the video, really digest that, and then see if you can try number 2 on your own. Start it again when you're ready. I'm going to go ahead and walk through it. Okay, h of 1. We're going to be taking 1 and plugging it into our h. So this is 2 plus the integral from 1 to x of f of t dt. 2 plus 1 to x, in this case my x is 1, f of t dt. So we're finding 2 plus the area from 1 to 1 of the function. And remember, this is a 4.3 property, right? 1 to 1 is a 0 area. We haven't actually moved it all, and so we have no area. And so 2 plus 0 is 2. Okay. Okay, number 3. We are asked to find g prime of negative 2. G of x is this integral, so g prime is going to be the derivative of the integral from 1 to x of f of t dt. right? The derivative of my g of x, integral from 1 to x of f of t dt. Okay, this is 4.4b. We're taking the derivative of an integral. This is second fundamental theorem of calculus. So I'm going to go ahead and take this upper, and I'm going to plug it in. So we have f of x times the derivative of the upper, which is 1, minus, take the lower and plug it in, f of 1 times the derivative of the lower, which is 0. So f of x times 1 minus all of that 0 is just f of x. Okay, so g prime of x equals f of x. Okay. Go ahead and write that underneath here so we have it all on one line. Okay, which means that if I want to find g prime at negative 2, g prime of negative 2 equals f of negative 2. And remember, f of x is a y value, right? What's the y value at negative 2? F of x, y equals, right? The y value at negative 2, well, here's x equals negative 2. Its y value is 3. Again, take a moment, digest that. If you need to, rewind the video, play through it again, and then when you're ready, pause it and try number 4 on your own. Okay, h prime of 0, so we also need to find h prime of x before we can plug in 0. So we're going to take the derivative of our h of x here. 2 plus the integral from 1 to x of f of t dt. Okay, the derivative of 2 is 0. And the derivative of an integral, second fundamental theorem of calculus, I'm going to take my upper and I'm going to plug it in, times the derivative of my upper, minus take my lower, plug it in, times the derivative of my lower. All of that 0, so we have 0 plus f of x times 1 minus 0. Which is just f of x. So h prime of x equals f of x. Okay, so now that we know h prime of x, we can figure out what h prime of 0 is. H prime of 0 is going to equal my f of 0. And f of 0, a y value, right? F of x and y are the same thing. My y at x equals 0 is negative 1. Okay, last one here. So we have an integral is area, f is a point, and so here we go. G double prime of negative 2. Before we can plug in negative 2, we have to first figure out what is the second derivative of g. Well, second derivative is the derivative of the first derivative, right? So g double prime of x is the derivative of g prime of x. Well, here's g prime of x. G prime of x was f of x. So the derivative of g prime of x is the derivative of f of x, f prime of x. And the second derivative, the derivative of the first derivative, is f prime. Okay, and so g prime of negative 2 is equal to f prime of negative 2. This is your unit 3 piece. A derivative is the slope of the tangent line at that point. So f prime of negative 2 is what's the slope of the tangent line at negative 2? Well, here's negative 2, and if I drew in my tangent line there, I'd have an issue, right? Because I could draw in a negative tangent line, or a positive tangent line, or a 0 tangent line, right? That's a cusp, which means this derivative, okay, does not exist because there is a cusp. Okay, so there's too many tangent lines I could draw in. This is different than, for example, if I drew in a tangent line there, definitely positive. In fact, I could even calculate this by doing rise over run. Or this one, which is definitely negative, and I could calculate that one by doing rise over run. Right? Here we have positive, negative, and 0, and an infinite number of other positives and negatives, because it's a cusp. Okay, see if you can try that one. Okay, so we have h double prime of 0. Hopefully you've paused it and tried this on your own at this point. Okay, h double prime of 0, again, can't take the 0 and plug it in until we actually know what h double prime of x is. So the derivative of the first derivative, well, my first derivative of h equals f of x. So the derivative of my first derivative is f prime of x. The derivative of f of x is f prime of x. So now we can figure out h double prime of 0. That's equal to f prime of 0. What's the slope of the tangent line? That's what a derivative is. Slope of the tangent line at x equals 0. If I drew in my tangent line here, at x equals 0, that tangent line is horizontal, which means that my slope is 0. Okay. And there you go.